Okay, so today we are solving quadratic equations again, except we're going to learn a totally new way of how to do it. To recap, yesterday's goal, to solve quadratic equations by factoring and setting equal to 0. So this is where we took those polynomials, we factored them, and then we took each of those factors and set them equal to 0. This way we could find out what all the x-intercepts were. Now, it'd be nice if that's all we ever had to do, right? But sometimes, as you'll see in today's lesson, is we're going to have quadratic equations that won't factor. At least they don't factor using any of the methods that we've learned so far. So we have to have another way to do that. And when that happens, we use something called the quadratic formula. So today's goal is to solve quadratic equations. The equations are going to look pretty much the same as what we saw yesterday, but we're going to use the quadratic formula in order to solve them. Now, to start here, this is actually an equation that was in yesterday's lesson, and I showed you this graph. So here's an example of a quadratic equation. It's just like it's a function, right? But it's not linear. It has this parabola-shaped graph here. Now, one way to solve this is what we already learned, right? We learned how to do this by factoring. So I would say, okay, well, if I set y equal to 0, if I'm trying to find out what those intercepts are, and then I factor this, well, factors of negative 12 that add up to positive 1 is going to give me x plus 4, and then x minus 3. So we take this polynomial and we factor it, and then we would set each of these factors equal to 0 and find out what our x-intercepts are. This you can probably do mentally, right? So how does this one equal 0? Well, x would have to equal negative 4. How does this one equal 0? Well, x would have to equal 3. So our x-intercepts, or our solutions to this quadratic equation, are negative 4 and 3. Now, you see that in the graph here, right? Here's negative 4, and here's 3. But we can also do this using the quadratic formula, and here it is. It looks a little bit crazy. It's x is equal to, so in other words, our solutions for x, those x-intercepts that we're looking for, are equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in case you're wondering where those a's, b's, and c's come from, they simply come from the standard form which we saw for writing any quadratic polynomial. So this is when we're talking about a, b, and c, we're referring to these numbers here, these values that we see written in a quadratic equation. Okay, so now let's actually go back to the one we just solved here. So this is the exact same equation that we just solved a moment ago, but we're going to solve it using this formula instead. So I'm just going to substitute everything. So the first thing we do is we say, okay, x equals, so let me switch to my marker here, x equals, now, negative b, right? So the first part of this is negative b. Well, b is 1, so negative b would be negative 1. Negative 1 plus or minus. And remember, that's there because every square root has a positive and a negative, so we always have to write plus or minus. There are always two roots whenever we're calculating something with a square root. B squared, well, b squared is just 1 squared, so this is the square root of b squared, or 1 squared, minus 4, 4 is a constant, that just appears in the formula, times a times c. Well, a is 1, and c is negative 12. So this will be times 1 times negative 12, all over 2 times a, and a again is positive 1. So there we have it. We've substituted everything. Now we got to simplify this. And I think the trickiest part here, most of the work lies in simplifying this part here that's in the square root. So that's going to be, well, I'll leave this alone here, this negative 1 plus or minus. Now let's see here. Let's see if we can do some of this mentally. Well, 1 squared is 1. And then I have negative 4 times 1 times negative 12. So I have 1 squared, which is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. So you can see that this whole thing is going to come out to the square root of 49. Now, square root of 49, I'll bet you can do that one in your head. If we square root 49, that's just 7. So this entire thing comes out to 7. Now, it won't always come out to something neat and tidy like that, but for this one it does. And then all over 2a, so 2 times 1 is just 2. Now, once you're here, you're essentially done. This is basically We have just 2 small steps left to get our answers. There's 2 problems we can solve here. We can get an answer for when we add 7 to -1, and we're going to get a different x-intercept when we subtract 7 from -1. Because remember, this is -1 plus or minus 7. So let's do the addition one first. Well, -1 plus 7 is 6. 6 divided by 2 is 3. So one of our solutions is 3. And then I have -1 minus 7. So -1 minus 7 is -8. -8 divided by 2 is -4. So our answers, once again, using the quadratic formula, are 3 and -4. Now if you go back just a minute here to our original answer, here's our, we originally factored this, right? We factored it into x plus 4 and x minus 3, and then we solved each of them. We set them equal to 0, and we got -4 and 3. So there they are again. So this is just to sort of demonstrate how the quadratic formula is another way of solving problems like this without factoring. And you're going to see that this is very useful today because we're going to see a lot of problems where it's impossible for us to factor, or rather it's very difficult for us to factor. So this presents an alternative method that we can use to solve any quadratic equation. Okay, plenty more practice coming. This is good for now. Talk to you soon.